Hi, my name is Tom. I'm going to show you how to convert binary numbers to decimal, decimal to binary, vice versa, or the same type of conversions between hexadecimal. So, first thing we're going to do is kind of go back to the basics of first and second grade. So, when you did a number like say 1238.56, you kind of broke the number down into places. You call this the ones place, tens place, hundreds place, thousands place, and this would be the 1/10th place and the 1/100th. So really, if you think about that, go back and look at these numbers again. 1/100th, 1/10th, 1, 10, 100, say 1,000. Those are all powers of 10. So any number raised to the 0 power is 1. 10 raised to the 1 power is 10. 10 raised to the 2 power is 100. 10 raised to the 3rd power is 1,000. Likewise, 10 to the minus 1 is 1/10. 10 to the minus 2 is 1/100th. So binary works much the same way. So I'm just going to erase this for a minute. So just keep that in mind. Most number systems are based on that. The other thing to keep in mind is that decimal is base 10. As you can see, everything's raised to a power of 10, and they're 10 symbols. So we have symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, there's 10 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just keep that in mind. Whatever the base is for your number system, if it's base 2, you need 2 symbols. If it's base 8, you need 8 symbols. If it's base 10, you need 10 symbols. So let's go back. Now let's kind of do the same thing for binary. So in binary, since it's base 2, you're going to have a 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and likewise you could have 2 to the minus 1. But if we separate those into columns here, we can also call 2 to the 0, anything to the 0 power is 1, so that's a 1. 2 to the 1 is 2. 2 to the 2nd power is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16. Keeps going. So if you have a binary number, we just want to evaluate one. Say it's I don't know, 1011. We just fill that in here, 1, 1, 0, 1. And then you basically just add up the powers of 2. So there's 1, 1 in decimals, that'd be 1, plus, there's 1, 2. There's nothing in the fours column, there's 1, 8. So that would be 11 in decimal. So 1011 in binary, I'll just put a 2 down there for base 2, equals 11 in base 10. So that's fairly simple. If you want to try some more, or let's do a counting exercise. So basically, I'll kind of keep this up here, and we'll count 0 through 8. So you need 3 digits to do that. So 0, of course, would be 0, 0, 0. A 1, go like that. So it's 2 to the 0 power, which is 1. 2 would just be like this. So you have nothing in the ones column, 1 in the twos column, nothing in the fours column. If you want to go to 3, you have a 2 and a 1, that makes 3. If you want to go to 4, 1 in the 4's column, nothing in the 2 and 1 column. 5, 6, 7. Now if you try to get to 8, then you have to use this other column over here, which is getting near the bottom of my screen. But anyway, that's how you would count in binary. The other thing to keep in mind is binary and hex are often used pretty interchangeably in computer systems. So what we're going to do here is let's do a quick base 16 or hexadecimal using the same method here. So you have first column will be 16 to the 0, which is 1. 16 squared, which is 16 to the 1 power, which is 16. 16 squared is 256. 16 cubed, I'm not sure what that is right off the top of my head. So anyway, in hex, the other thing we said, if it's base 16, which is what hexadecimal is, you need 16 symbols. Well, we only have 0 through 9, which makes 10, so you have to kind of create some symbols. So basically, you've got 0, 1, 2, through 9, just like you do in decimal, but since it's base 16, you have to have 16 symbols. So you got 10, 11, 12, 13, 14, 15 symbols, so that's 16. But the way this works for digits in hex, 0 through 9 are the same, but when you get to 10, you use an A, 11's a B, 12's a C, D, E, and F. So with that in mind, let's just evaluate a couple hex numbers. So one would be like, how about like A1? So A1 in hex would be, let's do it over here actually, go back. A1, so it's 16 to the 0 is 1, so one of those. A is a 10, it's 16 to the first, so it's 10 times 16, which is 160, so that'd be 161 decimal. Now the other thing about hex, you'll usually see a dollar sign written in front of it. So it might be like $ A1, that means hexadecimal A1 equals 161 decimal. Or sometimes you'll see it written like this, the 0 and X, and then A1. So if you see either one of those things, it means it's a hex number. Couple more examples or interesting things. We often hear of bytes, which means a byte is 8 bits. A bit means a binary digit. So a byte in its binary form will have 8 bits. So normally you have the bit numbering like this. You start at 0, 5, 6, 7. So they're 8 bits, but remember, bit 0 is the first one. So let's couple of things here that are kind of interesting. In 1 byte, the biggest number you can represent is 255. So we'll take a look at that. So the biggest number would be if you fill all these with 1s. So remember, these are powers of 2 essentially. So that would be 2 to the 0 is 1, plus 2 to the 1 is 2, 2 to the 2 power is 4. So basically you just go up in powers of 2. 16, 32, 64, 128. So like 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128. So if you add all those up, you get 255. So another way to look at this, this is in binary, right? If you want to convert that to hex, there's a method. You basically divide these 8 bits into groups of 4, and then you turn each binary number into the hex number. So if we want to do this in hex, let's see, one way to do it is, or maybe an easy way to do it, is just figure out what this is in decimal. So it would be 2 to the cube, 2 to the third power is 8, 2 squared is 4, 2 to the first power is 2, 2 to the 0 power is 1. So 8 plus 4 is 12, plus 4 is 14, plus 1 is 15. So I looked that up over here, and that's an F. So basically, this is an F in hex. You can do the same thing with the other side, since it's the same bit pattern, but so that would be FF. So basically 1111111 in binary is FF in hex equals 255 in decimal. So you can kind of go back and forth with these things if you want to convert. Just do a couple examples here. So if you see a number like, I don't know, C8, what you can do is break this down into 2 chunks again. So C8, you can kind of think of it, there's a couple ways to do it. If you want to do it in binary, you figure out what 8 is in binary. So remember, I'm going to erase this again a little bit. Give me some room here. C8. So if we have 2 to the 0, 2 to the 1, 2 squared, 2 cubed, what is 8? Well, 2 cubed is 8, so it would just be 1, 0, 0, 0. A C is a 12, so same thing. I'm going to go 2 to the 0, 2 to the 1, 2 squared, 2 cubed. How do I get 12 out of basically an 8, 4, a 2, and a 1? Well, 8 and 4 is 12, just C, so I can go 8, 4, don't need any 2's, don't need any 1's. So C8 in hex equals 11001000 in binary. Probably an easy way to convert that to decimal would go back to thinking about, I've got 2 columns in hex, here 2 digits, so the first column is 16 to the 0, next column is 16 to the 1, I've got a C8, so I could go C is 12 times 16 to the first power plus 8 times 16 to the 0, so that's 12 times 16, which I'm going to have to do over here. I don't know what that is. So 192. So it's 192 plus 8 is 200. So 200 in base 10 or decimal, whatever you want to do. So that is that's my short lesson on hex, decimal, and binary numbers. One other number system that's used once in a while, not too much. Once in a while you'll hear Octo, which is just Octo is base 8. Whoops. Base 8. So basically you're going to have 8 to the 0, 8 to the 1, 8 to the 2, 8 to the cubed column, so on and so forth, which is 8 to anything to the 0 power is 1, 8, 64, what is 8 cubed? I don't know if it's 256, let's see. So that'd be 64 times 8, 32. So it's 512, sorry. So in octal, it's base 8, you only need 8 symbols, so you have the symbols 0, 1, 2, 3, 4, 5, 6, 7. That gives you 8 symbols, so there's nothing more than higher than a digit 7 in octal. So if you had 67 in base 8, that would be the same as 6 times 8 to the 1 plus 7 times 8 to the 0. 6 times 8 is 48 plus 7, 56. So 67 in base 8 is 56 in decimal. You can likewise kind of convert things back the same way, but you've got to form your number in terms of powers of 8. That concludes my simple lesson in binary and hexadecimal numbers. Thank you.